Welcome back to my channel. This is Pragya Jain, and in this video we are covering a topic of data preparations. So in this video we are creating some sample data, then performing operations like add an index field, changing misleading fields, re-express categorical fields, standardise numerical fields, and identifying outliers. So let's get started. So first we have imported some libraries here, that is pandas, numpy and standard scalar. Now we have created a sample data so that we can perform operations on it. So first is data is equals to name, age, salary, gender and cities. These are the columns, and Alice, Bob, Charlie, David, Eve and so on. These are the values for the particular column that we have assigned. Now data is equals to pd.dataframe data. We have created a data, you can see here. Now we have to perform some operations on it. First we are adding an index field. df index is equals to range 1 comma len df plus 1. In the previous data, as you can see, the index is starting from 0 to 4. This is by default index, but we are adding an index field to it which is starting ranging from 1 to df len plus 1, that is 5. The length of this index is 0 to 4 plus 1, that is 5. So the index is starting from 1 to 5. Now the another operation we are performing is changing misleading fields. So here is, let's assume that the age field has a type, and suppose we have age greater than 100. So we have to replace that age with the median of the rest of the ages. So the age field is equals to df.loc df age is less than equal to 100 age.median function. This function will help you to take the median of all the other values, or you can say all the other ages other than the age which is greater than 100. Then we have printed the age df. You can see the output here, that is the age greater than 100 is for the third one is 120, which is greater than 100. So it is replaced by 29.5, which is the median of all the rest other ages, which is less than 100. Now the third operation we are performing is re-expressing categorical fields value. Now we converted the gender and the city to the numerical codes. For female we are using 0, and for male we are using 1, and for city we are using index values. Suppose in early data the city is indexed from 0, 1, 2, 3, but now we are using index, so it will start from 1 to df plus 1, df len plus 1, that is the length plus 1 will be the last index of the city. So you can see the final code, final output here, that is before the city will be NY, LA, SF are like this, but we have categorized this from the index, like it will indicate the index from 0, 1, 0, 1, 2 and 1. Now we have using the gender. For female we are using 0, and for male we are using 1. Now the fourth operation is standardizing numerical fields. So we have using a standard scale function here for standardizing some columns of our database, that is age and salary. So age and salary have some numeric values, but now we are standardizing it by using a standard scalar function. So this will look like this. Previously the age and salary will have 25.0, 30.0 and salary which have 50,000, 54,000 values, but now we are standardizing the age and salary, so it will look like minus 1.474521 and so on. Now the fifth operation is identifying outliers. We'll use a z-square method for identifying the outliers. Here we have age and salary. So if the outliers are those if the z-score is greater than the threshold and the threshold is given here is 3. We have given that threshold. So now the outliners are all false because no z-score is greater than the threshold, so it will indicate false value. Now the under this we can use also display the rows with the outliners. As we have seen above, there is no outliners in the data, so it will indicate 0 and the data is empty here. You can see rows with the outliners is empty database and it will show the column names only because we have no data with outliners, that is the z-score is greater than the threshold. We don't have any rows like that. So that's it for the video. I hope you like it. Thank you.